So today I wanted to work on cleaning up the XML parser stuff that we did yesterday. Hello, hello. Doing good. How about you? Doing good. Doing good. Had more money, honey, would you? Dude, this song was such a fucking banger back in the day. It's a terrible song, an absolutely terrible song, but it just sounds so good. Okay. Yesterday, yesterday we kind of got to the point where we could kind of like do some XML parsing, right? So we kind of like walk this Wayland XML file, and we're trying to basically get to the point where we can extract all of the pieces of this thing that we care about to generate our Wayland protocol implementation. So in here we have this like Wayland bindings. This is like generated code from the XML. So we say like, hey, there's a WL display interface, and he has a sync command, and we have a get registry command, and that comes from this thing. He has like a WL display interface who has a sync command and a get registry command, right? So this is kind of coming from that, and we kind of got to the point where we got something, but it's not very good. Like all of the code in here is pretty rough, and I think our abstractions make it quite difficult to work with. So we kind of like now understand what we want to do when we're parsing, and now I think the plan for happy hour is to try to make it less shit. So I think something we're doing a lot is if we have like a bunch of like stuff, like if you have like some like content with content here, and then in the middle you have like a bunch of garbage, right? Whatever, right? You have something like this. Something that we're doing a lot is like trying to say, can I advance to the next interesting point, like here, right? So if my cursor is like here, or I guess it's kind of technically going to be like here after parsing the element header, then he's going to go rip through all this stuff, and we're kind of trying to get to the point where we end up here. And the way that this is happening right now is we're kind of using like Zig's read interface. And that means that like you can't kind of like get a thing without reading it. And so we're kind of always going one past the thing that we're looking for. So I think we need some sort of abstraction that allows us to like read until a thing happens. Right? That's kind of like abstraction thing that we want from it. Another thing that we want is we probably want to be able to stash data, like buffer data for return to caller, right? So if we have something that's like content, XML parser again, yeah, we're gonna work a little bit more on it today. Hopefully it's just a 2-day exercise. It could turn into 3 days. That'd be kind of fun. But then back on GPU stuff. For sure, we're going back. There's a second part. Second part, I guess. I guess calling it again is strong. We're continuing on. So like if we have like key equals value, I guess this is being quotes. Key 2 equals value 2, right? We kind of want to like keep this whole line in memory so that when we return to the caller, they can reference this memory. That's kind of like the idea. So we want to be able to return something that's like output has like name is like typical like Zig string stuff. Key 1, key 2 type shit, right? Like we want to be able to put something along these lines. But the problem here is if we need to like keep the memory somewhere. And so I want to be able to like buffer the data in some buffer and then return pointers to it, essentially. I don't think I want to do that for content really, because the goal here is also parse without reading whole file into memory. Right, so we kind of want to like have like some segments in memory now, but not like everything. This might look like buffering the data it could look like this, right? This is like one option, but another option is kind of like this, right? Where we kind of just like stash only the parts we care about. That's an option. However, I suspect that this will make more sense with the way the abstractions are going to work out. So kind of what I'm thinking, we're going to have like an XML. Maybe we'll call this like a, we can call it buff reader for now. I don't think that this is really, this has like a name conflict with standard library. And also like, that kind of indicates that we're doing something else here. Yeah, okay, so we'll start here. And I think that likely we are going to have some sort of like circular buffer inside, to be honest. A circular buffer sounds like it's going to make a lot of sense. Why use has an XML parser today? I don't know what that means. So I think maybe we start with like a circular buffer. Maybe we implement it in here for now. So we're gonna have some sort of like buff, and I think that this buff will probably be a fixed size so that we can kind of do everything on the stack. Kind of makes sense to me. Fix me parameterize buff size question mark? Probably not. We probably won't do that, but let's at least note that we might want to do that. We're gonna keep ahead where we are in the buffer. How many bytes do we need for hold on. How do I calculate this? 2 to the power of 16. 2 to the power of 8. Right, okay. So we'll do U16s here, I guess. We'll do U16s. And now what? Now what? I guess we're gonna have some sort of like function that's like read until. Yeah, sure. I guess we could keep the reader inside, or we could feed him in. If we called this a like just like XML buffer or something, or just like, I guess for now it's a circular buffer. I'm sure that this will, well, it's gonna have functions that like read until a thing happens, right? So we're gonna call this like, yeah, buff reader really is the best name for now. It really is the best name for now. We'll figure it out later. And what's he gonna do? What's he gonna do? I guess he's not really, he's going to like make sure that we have data in here. Hand wavy, right? So I guess first we scan our current buffer. Then we look if we have if the thing we are looking for is there, no reading to do, right? But if it's not, read until it is kind of the loop here. So I guess kind of like the first step here is to just kind of make like a circular buffer reader. And maybe this stuff will be tacked on top later. So let's just do like a read function. Or maybe we'll call this like populate. Read, I guess that's fine. And I think that what we're gonna do is we're gonna try to like split this into two components, right? Because your circular buffer is like in memory as like some stuff, right? And you might have like kind of like null pointer, like you could kind of be like, we have stuff from head to tail, right? So that like one option is that like G, we kind of have like this stuff, right? And so like we can kind of, this is our head, this is our tail, or other way around, whatever. Which means that we can read, we can start putting data in like here. But if we want to get as much data as we can, we have to do like a second read to here. So probably what makes sense is probably chunk our reads so that we read like this stuff and this stuff. You could even maybe populate like the full thing at once with a vectored read. Right? There's this thing called like pread that lets you basically pass in. No, this is not what I'm looking for. There's like IO vectored reads in the standard library somewhere. I guess I'll open a new window. C vectored reads. This is supposed to let you basically do like, I'm gonna read into these 4 buffs at once type shit. Write V. That's what I'm looking for. Read V probably? Yeah, nice. And then I don't know if like Zig has wrappers around read V. That'd be kind of cool. That'd be kind of cool. What am I looking for? Standard library. Vectored. Read V. There's POSIX read V. I guess our generic readers don't necessarily have that. Kind of surprising, to be honest. Read all array list, read all alloc, read at least, read rounded, read bytes. Yeah, it doesn't really seem to have vectored reads. So I guess if we want that, we drop down a level. So this is going to take a file. And this is basically going to try to read as much stuff as it possibly can. So we're going to take like, maybe it makes sense to have like a split content split or something. Maybe content. And this is going to return like split content, right? Where this is going to try to give us like 2 contiguous slices. So I guess we'll call this uninitialized or readable content. And so this is going to kind of give us like this and this in one type. Buffer pair feels like the right thing. So this is going to give us like 2 U8 slices. And I guess we're going to look at, we have to decide which one is head and which one is tail. I guess we'll call head, tail, it depends on if you're thinking about this as like stuff you're pushing in or stuff you're reading out. So we'll call this write pause and read pause. And that will just make things easier. It will make it easier. We are going to have to initialize these indices. So initially they'll be set at 0. And I think what I want to do is, no, we'll see how it goes. So let's think about like the base case. We have length of the buffer, write pause, and read pause. So the simple case is we read into A is going to be the 0 to the read pause. I think that makes sense. Okay. And B is the write pause to the length of the buffer. Yeah. I guess we don't even have to specify the end. We can just kind of say, give me everything. Give me everything. And then we can just return this. So I guess it's like kind of like this. Y is my editor crash. There we go. Okay. So then we're going to have some readable content. So let's think. So we're going to say f handle is going to be the handle that we're going to do a stud POSIX p read on. No, read v, sorry. And we're going to have to make our IO vector here. So readable content is our buffer pair. And our IO vector is just going to be based off this thing, right? So we have to make some of these. I guess let's, sorry, I want to go back and get this whole thing. So we're going to do const read v arg is going to be a stud POSIX IO vec, but an array of these things, right? Is that what he wants? He wants a slice of them, yeah. So we're going to do this. And each one is going to have a base and a len. Arguably, this should just return the IO vectors, but whatever. I'm okay with doing it this way. And then we just do this for B as well. And then we should be able to just pass this as read v arg like this, but he has to be a slice, not an array, so we put an ampersand here. I believe that this will work fine. So at this point now, we are going to have to advance our right pointer by however much it moved. Right? Kind of hand wavy. Now, what does this actually return though? Man to read v. Return value. Return the number of bytes read. Right, so we can just do this. However, we might have to handle wrapping. Right? Because it's a circular buffer. So if we start reading here, if we try to read all of this and it all fills, then our cursor is going to end up over here. Oops, sorry. Which I think is honestly fine. It's honestly fine. I saw this trick at some point where you can kind of implement these circular buffer indices as like length of buff times 2 space. So the read pause will always be kind of like in the range of 0 to buff len. And then the write pause will always be in the range of 0 to buff len times 2. And then write pause minus read pause always has to be between 0 and buff len. And this lets you kind of represent the idea of like length and capacity kind of like at once. If I remember correctly, I always remember having trouble with the idea that in a circular buffer, you have to, a full buffer and an empty buffer look the same, right? Like if you have like a buffer with 3 elements, right? And you're, say like you start fully empty, right? So maybe we'll mark empty with underscores, right? So in this case, we can say that the head is here and the tail is here. Cool. So we read one thing, and we move the head over. Then we read another thing, we move the head over. We read another thing. Now where does the head go? Well, he can go here, right? Out of bounds. But then what happens when we read something? Well, we consume this, and now does this go back over here? Like, because that's how it was when we were reading before? Well, if you kind of just leave it here and then like mod by the length of the array, then he's kind of like implicitly there. So you can kind of represent this as like a kind of like shadow buffer over here. You know? So it's kind of like repeated. So you kind of put the this here now. And now you can kind of have like simple, like the gap between these two things is very easily calculatable. I think. So I wanted to try doing it that way. I want to try doing it that way. So here we can say we write pause as we write, kind of as is. We shouldn't ever get, this should never end up as larger than buff size over 2. What we have to do is, I guess, when we read, when the read wraps around, so like we read this moves forward, we read this, now this moves forward again and they line up, and then at that point, we kind of bring them back here. You know what I mean? You know what I mean? So the write is only ever decremented when we pull things out of the circular buffer, which we aren't doing yet. So I think it's fine. I think that calling this read is just very confusing because this is actually writing into the buffer from the file. So I think I want to call this like populate. And I think then we want to like consume bytes from the buffer. I don't know yet. I don't know. And I guess we're going to say that we want it to consume like some amount of bytes. Hand wavy. And I guess this is also going to return a buffer pair. And this is where we're going to do like read pause plus equals amount if read pause is greater than self buff len or equal to, because the read, yeah, it's gonna be something like that. We'll have to write some tests because I'm not 100% sure here. Not 100% sure. I guess this will return nothing. Here's what we're gonna do. We're gonna have like function like peak, or maybe. Okay, this is now supposed to be writable content, not readable. I think that makes more sense. And then we can get content or something. I don't know. We'll figure out the names later. So this is going to return a buffer pair. And this is like the public API. So this is going to return basically what? Like self write pause percent A goes from, can we copy paste this this thing down? So we have read and write are kind of like this. So the data is like write IDX minus read IDX. So we kind of go from like buff goes from self read pause to self write pause, right? But write pause might be too big. The write pause might be too big. So we take the minimum is the minimum. How do I, is there like at min? Yeah. Of the write pause and buff len. Okay. B end is going to be the minimum of write pause percent 2. Or sorry, self buff len. I guess that's kind of it. I think that's it, right? Because then if he's like here, he's going to end up at 0, and then the B will be nothing. Yeah. Yeah. So I think it's like this. And this has to be AN, sorry. Yeah. Okay. So we can kind of like look at the content. We might want to, we might have to write some abstractions around this buffer pair thing, but maybe not. Maybe not. We'll just kind of see how it goes. So if we do this, consuming just means self read pause minus equals self buff len, and write pause also equals self buff len. And I think that means we have enough where we can write some tests here. I think. It would be nice to not have this API tied to files. That would be nice. Because then we don't have to deal with like temporary file handles and stuff. So let's do this. Vector reader. And he's going to be probably a function. We'll call this file vector reader. Here we go. Here we go. Which is basically going to do this. So he's going to write into, I guess, a buffer pair for now, or like a slice of buffers. Right, so we can do kind of like something like this, right? And then we can say the I vector comes from these. However, if this has an unknown size, then we can't do this on the stack. So let's kind of fix this to buffer pairs for now, because there's no reason to get like abstract with this shit. Okay, then we can have like another implementation of this. I guess we need the file that we're reading from. So I guess this kind of lives here. And maybe as a pointer, kind of hand wavy. I guess it's fine. We can do it this way. Okay. So then we get like self as a file vector reader and buffs as a buffer pair. And I think we're chilling. Now this just has to come from buff pair. Okay. Then we can have like array vectored reader, which is going to have like I guess it'll be a reader, IO vectored reader, standard vectored reader. So he's gonna have a reader inside. Yeah. I like this. So he's gonna have a reader inside. So he's gonna have like a comp time reader is a type. He's gonna return a type. Okay. Return struct here. This is reader. Const self is equal to this. And this is self now. And just instead of doing this p-read, he's going to just try to read into A and read into B. This also has to return the amount read. Yeah. So here we'll just go like, we read into A, then read into B. So here we read into buff pair A. We'd say written is equal to this, written plus equals read into B. Yeah. That feels right to me. Will the parser be stacks or DOM based? I don't know what either of those things are. I'm just doing whatever makes sense to me. Whatever makes sense to me. I think we are streaming top to bottom, trying to emit events of like things that we are seeing as we go. Not trying to like track a hierarchy of any form, but just like leaving that up to be leaving that up to the caller. Okay, so I think that we have like kind of the pieces we need to write a test now. And we will call this, well, I guess we should start with the vectored reader test here, just to make sure that we have like good building blocks. Stud vectored reader. So I guess we're going to have, let me think. Stud vectored reader fall around I guess we need a function here to generate the thing. It's typically the way we do this thing. So we take in a reader is an any type here, and he returns a stud vectored reader with type of reader. Here we go. And he returns reader equal reader, boom. So then we can say const vectored reader is a stud vectored reader around some reader. So I guess we need a reader. So let's have some like data. Hello world. Hello world. We'll have some output buffer. Speaking of vectors, let's hear it. So let's try to read this in two chunks, right? We'll have like A is going to be, we'll do 5 characters. And then 10 characters for B. Okay. Which means that here we should be able to create a stud vectored reader around this thing. I guess we create our reader. So our reader is stud IO fixed buffer stream around data, right? Boom. Fixed reader is equal to this, and then we use fixed reader.reader interface here. And then we try to read, so we say vectored reader read into our output. And then we should have assert. Okay, so we have the bytes read is this. Okay, and we should have the stud testing expect equal. Is it expected first? So we expect data len bytes read. Yep, that makes sense to me. And we also expect that expect equal strings. So we expect that we should see HELLO, 5 letters in the first string. And then we expect to see world in the second string. Hell yeah, dude. Okay, so he's mad because the fixed buffer stream does have data that he modifies. Speaking of vectors, Zig question mark? Yes, we are in Zig, for sure. I think we need to write try here. Is the NeoVim config on GitHub or anywhere as perused? Nope. Nope, I have not placed it anywhere. But it's nothing crazy. Nothing crazy. The pieces here are telescope, I use a lot. LSPs, I use a lot. And then like NVIM comp for autocompletion with LSP integration. What else? Those are the main things I use. I guess color scheme is like Sonokai with term GUI colors off. And I think that's pretty much it. Pretty much it, with a couple heat mines, but whatever. Expected U8 found const U8 because. Wait, what's he mad about? Oh, because these are already slices. Okay. And then these need to be tried. And then expected this stuff found. Whoa, what's going on here? What's he pissed about? Expected this found usize. Oh, I see. Oops. Error union is ignored. Down on these test expressions. Expected this output, instead found this output. Those are the same fucking output. Oh, he went too far? He went too far. This is also red. I don't know why it's written. Bytes red. Boom, boom. So he's going 1 byte too far. Is that because, like... Oh, because I'm a dumbass. And B has to go from... we need to track how much was read here. Right, so this has to go from 0 to 5 bytes read minus 5 or something. Or 0 to bytes read minus a len, I guess, is the trick here. I think that makes sense. There we go. Nice. Nice. Nice, nice, nice. Okay, so our stood vectored reader works, which means that we can start running tests around our circular buff reader. Circular buff reader, we'll call it. I don't know. We might have more tests later, but for now, we will kind of do like a similar setup where we create a vectored reader around some data. I would love to be able to parameterize the size of the buffer just so that we can write like use a smaller buffer for our tests. So let's kind of change this to a function. Size is a comp time int, I guess. And he returns a type. Which means that this returns like this, and this gets turned into a return, and anywhere we said circular buffer down here, it turns into self. Boom, 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 boom. Okay. And then here we need const self is equal to this. Boom. Boom, boom, boom. So now we can create a circular buffer reader. And can we make the size like, I don't know, 10? I don't know. Lazy dog. We'll use a little bit of a longer string. Circ CBR, I guess we'll call it, for circular buff reader. And let's do something that's like CBR populate, right? And we are going to populate this not from F, but from our vectored reader. Which comes like this. And then now our vector, we call read with the buffer pair on that thing. So we just call vectored reader read buff pair. Okay. So after we populate this thing, we should be able to get the content here. And I wonder here if it makes sense to do some sort of like it would be nice to compare this thing easily instead of having to split it. Rename to spherical buffer is very funny. Very funny. I like it. This comes populate through the vector reader. Yeah, okay. So our content looks something like this. We have content A and content B. So we kind of I guess we can kind of expect equal here the length of A. I guess we can even do expect equal strings. And I think that the way we implement this was that A is the small one in this case. Yeah. So here we expect A to be nothing. And we expect B to be the first 10 characters of this. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we'll start here. Right, so this has to be initialized, which means that we should have one of these like circular buff reader with a lowercase c that takes in a comp time. No, wait, we don't need that. We don't need that. We can just kind of do this equals undefined, which allows him to do this. Nice. Okay, populate ignored. Error unit is ignored on vector reader 164, so he needs a try here, right? Makes sense. Value view size ignored. Right, we forgot to do self right pause plus equals that. All right. And then we do an incast here. Okay, error unit is ignored on these expect equal strings. Okay, and then 157, obviously that doesn't make yeah, this is writable content comes from 0. This is 0. I don't know what the fuck I was thinking. But write pause might be greater than the buffer. It's kind of the opposite of this. Right? It's whatever, it's the opposite of this. So in our scenario, read is always less than write. So 0 to read will always be the second buffer. So the other one is just self write pause percent self buff len, and this will always go to the buff len here. Yeah. There we go. Which means that the I think this is wrong now. This should be swapped. I actually don't know. Maybe it's fine. We'll see. Zig test. Okay. So expected this found this. So it is the quick here. And then the second one should be empty. Expected this output, instead found this. Right, so this is now like this. Okay. So we've got like the first part done where we read the first 10 bytes. So now let's do like something where we go like consume like 4 characters. So if we do this and we get new content, we expect this to kind of look like this now. We've consumed 4 characters, so the at the beginning should go away. Which he doesn't like here, because consume here. Sure. Expected U16 found usize. It's fine. Okay. So that's good. Let's just confirm that if we fuck this up, it does in fact fail. Right, okay. So now, we should be able to read some more. So let's populate again now. And I guess what we expect here is that we see brown here. The quick brown, we should see the first 4 characters of brown. So we have 4 bytes that we've consumed from the buffer, so now the 4 bytes are in B. I think that makes sense. So it's actually like this is what we want. Found expected this output, found this. Whoa, whoa. Hold on. So this is fine. At this point, we have our circular buffer says quick. So here, A shouldn't have changed, right? Because we didn't consume anything from A. We shouldn't have. But it looks like we're overwriting A when we populate. Which is kind of surprising. Can we print out like the content of vectored reader buff? Is consume skip the same as skip? Skip doesn't exist in our thing right now, so I guess yes. He's mad here. Buff doesn't exist. Oh, it's not vector reader, it's circular buffer. It's supposed to just, yeah, like, basically, like, eat those bytes. Get them out of there. So this says fox jump. So we're actually missing brow, which means that probably our right is, like, backwards in some way. Writable content. Oh, I guess write pause percent buffland might be less than read pause. Right, that makes sense. That makes a lot of sense. So this should look like this. And if self read pause is less than this, then we have a problem. Yeah. Let's think. So we're like over here. We're like way over here. So there's 2 cases. One is that this is case 1. And then case 2 is kind of more like this. Let's do EF here. So this is our right index here. And our read index is here. So clearly we have to go to the read index if it is bigger than the right index. Yeah. So we'll call this A start. End is going to be, yeah, I was doing a font parser and rest the equivalent of consume is hella verbose. Oh, I mean, we're tracking everything ourselves. I mean, you could write the same code in Rust, right? Am I crazy? Right? We're just doing like a circular buffer on our own. And so you could write the exact same thing in Rust. I think it'd be fine. So this is going to be if read pause is greater than a start, read pause, else the end of the buffer. Yeah, that makes sense. Now, B, we can't just unconditionally start at 0, because what if we're in this case? I guess here, we're going to have like read, if this is read after start. Yeah. So if read after start, this is the A. And here we're going to do B start is equal to if read after start. We do like self read pause, because in that case there's no second component, so that will end up being a 0 buffer, 0 length buffer, else 0. Yeah. So then we can do B start here. That seems right to me. I guess B start is kind of actually A and percent self buff len in that case, which is kind of fun. Yeah. Because bufflen percent bufflen is 0. Cool. Let's try it. Nice. So now he says brow like we expected. I think. Yeah, nice. Nice. So remember that this is reversed. Like B is contiguously before A in this. So our buffer actually at this point looks like brow quick at this point. So if what have we tested so far? At this point we had nothing. At this point we had 1, 2, 3, 4 quick, right? I guess we'll mark empties with underscores. Okay. So here we've tested start to end. Here we've tested end wraparound, but we have not tested like an actual wraparound read. So maybe we consume so that we go through like 7 or something. Yeah. So we can do this. And that should turn into 1, 2, 3, 4, 5, 6, 7. So now if we do another populate, it should turn into brown, fox, j. I think. So we'll test here that we expect this to be nothing, I guess, and then row. Maybe it's the other buffer way. I'm not sure. I'm not sure which one ends up empty here. It looks like it's B A like this. Expected this output, found this. Whoa. Hold on. Okay. So here we get row. Did I consume the right amount of characters? 0, 1, 2, 3, 4, 5, 6, 7. I feel like that's right. I feel like that's right. Oh yeah, okay, so he's okay with that. And then B should be nothing. So this is the problem. Interesting. Interesting. Oh, because we have the same problem that we had over here. This is kind of just the inverse, huh? I guess it really is just the same. It's just this is reversed. So yeah. It's something like this. So we have A, we want to go from read to write. So this is read end. A end here. It's not the same. It's not the same. We still probably have to switch. No, let's think about this again. Okay. So the base case is god damn it. Okay. Self read pause does always seem like the first thing to look at. Then we either read to the write pause or buffline. That makes sense to me as well. So this handles the case. No, because yeah. That's right. B end has to be. Oh wait, this actually looks right to me. This looks right to me, but what is wrong here? Circular buffers are hard, man. Okay, can we write? So this makes sense to some extent. He's reprinting what was there before. Because he needs to take the min of the read pause in this. I'm pretty sure that's it. Nope. It's another one of these, like, if self write pause is greater than self buff len. Do we have to do something here? Let's think. So if write pause is like here, this is really simple. We just go read to write. And B, however, is less clear. This is the case that we're not handling correctly. So here we basically don't want B at all in this scenario. Now, what is the condition where we do want B? It's if we have wrapping around the corners, right? It's like we have something like this. Yes. Okay, this is the case we have. So in this case, we want to go read to end, which is what we're doing, and then 0 to write pause, which again is what we have right now. It's just that we have to switch on these cases. So I think this is like if self write pause is greater than self buff len, 0, else this. I think that's right. No? Other way? Yeah, other way. There we go. We made it. We made it. Hell yeah. Okay, so is there any other test cases that we haven't done? I guess we haven't populated in the case where it actually has to wrap around. So this becomes the quick brown. Oh, we have it here. We have it here. So then we expect something like round fox and J on the second half. Nice. Let's fucking go, dude. I think that's working. I think that's working. So yeah, I think that's fine. Now, I guess we have to finish reading as well. Hello, what is stood vectored reader? It's a wrapper. So we wanted to do vectored reads on a file using readv so that we can write it, like read one syscall, read into multiple buffers, because when we're doing a circular buffer, you have like a split of your data sometimes, right, where it's going around a corner, right? So you can't do like one contiguous read, you have to do two chunks of reads. So we wanted to use readv, but then we wanted to do unit tests around like the normal reader interface. And the normal reader you just read twice because they don't have like a vectored read interface. So this is kind of like fake vectored reader, I guess. But it's poorly named. So here we should do fix me. This doesn't do vectored reads, idiot. And the high level thing that we're doing right now is we are trying to make a circular buffer reader that will also allow us to start like peeking into the data. We're trying to make it so that the XML reader that we were writing yesterday has all of these constraints handled. So we want to be able to read until a certain thing without consuming that thing, right? So like basically read content until you see like an open angle bracket. Buffer data so that like the caller can like look at the data in this thing, which is going to be handled by like the circular buffer, I think. We're going to struggle a little bit with the concept that like this value, like we're going to have a thing that could wrap around, which is going to be a little annoying. But maybe we will like rotate the vector or something to make it contiguous or something. I don't know. We'll see. We will see. And then parse the original whole file. So yeah. Yeah, I wonder if all this like split buffer stuff is overkill. I wonder if we're gonna end up just calling like make contiguous all the time, then maybe this is silly. But I guess make contiguous will only happen in the case where we have a boundary that wraps around, like our element hits the page boundary or something, which probably won't happen that often. So maybe it's fine. Okay, so let's update our XML lexer to try to use this thing. Let's checkpoint. And okay, so we're gonna kind of try to remove kind of all of this stuff is what I'm shooting for. Well, I guess that's not true. I want name and attributes to like look into parts of our buffered reader. So it's really in buff that goes away here. It's gonna look something like this. Something like this. And I wonder if we can get away without an allocator. No, because this stuff needs allocation. Kinda hand wavy, theoretically. We could probably get rid of this. Probably possible without allocation, but we'll see. So it's all actually for peak. I think so, yeah. I do think so. We'll see how the how the API ends up. But I was gonna kind of try to shove a bunch of this like advanced stuff into that as well. Like I was gonna try, like, yeah, I think this like advance until whitespace thing, or advance while whitespace, advance until thing. I wanted to put those in our reader as well. But maybe that's not quite right. We'll see. Does this guy need a dinit? No, it's all in the stack, which is pretty cool. So inbuff dinit goes away. And surely we just don't build right now. Yeah. So like, can we just do this? I guess we can do it up here. Boom. All right. What else? Inbuff append. Okay, so this is anywhere we were reading now, we have to behave differently now. So I think what we're gonna do is like for now we'll write like a read byte on this thing. And this is essentially just going to be a wrapper around self read pause okay, we need like a len. Okay. And this returns self write pause minus self read pause. And then our read byte is going to, I guess we want this to be peak byte. And we'll say if self len is greater than 0, we can return self buff at the read pause. Yeah. Okay. And then the problem here is that this is kind of assuming that we are like consuming stuff from the buffer, and that's not really what we want. That's not really what we want. So we have kind of like another thing that we want, which is going to be the cursor. Right? We kind of have like three, like multi-stage read, right? We have like read from file to circular buffer. And then we have peak, like walk circular buffer until end of element, i.e. like if we're parsing this thing, say we have like all of this stuff in our memory in the circular buffer right now, right? Then we should be able to do like basically like a second cursor that ends here to say like this is where the element ends. This is where I've like read up to. So I almost want to be like write pause. I almost want it to be like data end. I want this to be like data start. And then I want like cursor. This might be like too coupled. But I feel like if the cursor is walking through this stuff, then it kind of makes sense. No, I think actually maybe what I want is like a way for us to extract up to a certain amount. So here we want like content, maybe like this. Content from pause. Yeah. Or maybe we put this on the buffer pair thing. Yeah. That makes way more sense. So we can do like kind of something like this. Yeah. So what happens here? If start is greater than a len, b start is equal to start minus a len, right? A len, right? Kind of. But what if start is too small? What if start is too small? This has to be like start is greater than or equal to a len. If start is greater than or equal to a len, it's start minus a len. Else, 0. Is that right? No. Fuck. If end is less than a len, there we go. We do one thing. That makes sense. So if this is less than or equal to, then we return a is equal to a from start to end. B is equal to nothing. Else if start is greater than or equal to a dot len, we kind of do the same thing, but it's start minus self a len and a end minus self a len. Cool. Otherwise, we are in the case where we're wrapping around the boundary. So a is going to go from start onwards. And b is going to look still like this. This would be b here. Yeah. I think it's like this. I think that's right. I think that's right. So let's make a buffer pair. So we'll do like a is equal to hello, b is equal to world. Let's slice this as 0 to 4. And we can do stud testing expect equal. How do we do this? Expect equal hell to BPA, and we expect nothing in B. Okay. Sorry, slice.a, slice.b. Then here we're gonna do slice from like 4 to 7 or something. So we should see O space were 1, 2, 3, 4, 5, 6, 7. Right? 0, 1, 2, 3, 4, 5, 6, 7. No, I don't really understand. Oh, oops. It's only 3. 4, 5, 6, 7, 4. 3. So 7 to BP len should go to this or something. Which means we need a len in here as well. I read somewhere that Zig comes with testing like Rust, but fuzzing too. Is this true? I don't know. I can see how implementing fuzzing would be easy in Zig, but I don't really know. I don't usually. I've been kind of light on testing recently, so we're kind of cheating a little bit. I guess we're like a little out of the loop. Why doesn't he like this? Don't you write ampersands here? No? Is this not allowed? Oh, maybe these have to be because these are non-const. The buffer pair is expecting non-const. So we have to do something like how do I do this? How do I make like a mutable string? Hmm. I thought that you could. I mean, you could always do this, but I don't really want to do it that way. Right? I know that this is a syntax you can use to make a thing on the stack, but I kind of was hoping that you could do like zig cast string to array. Zig compile time array string. I really thought this worked. Can I do like 5 U8s? Is that allowed? Oh yeah, it seems to be allowed. We'll find out. It seems okay with this, except clearly one of these is not 5 long. Oh yeah, he doesn't like this. Fuck, man. I mean, we'll do this for now. But I'm sure this is not the way. Hello dot star might work. Oh. Yeah, I'm kind of down with that. Good eye, good eye. Thank you. Thank you. So this should be expect equal strings on all these. Nice. Okay, so this looks okay. So now we can slice these. Why did I want to do that? I honestly can't remember. I guess we will try to build and see what happens. So, right, we're looking at peak byte. Ah, right. So we were trying to say, like, what is the content in this thing? And then we're basically trying to find. So this should be buff content here. We are trying to search in this string for this open angle bracket. Right? I guess. Which means that we kind of want to be like find something. I don't know. Yeah, something like this. I don't know. So we basically want to search in the first chunk index of scalar. Yeah. Yeah. So you find the index of the scalar car in A. If this return P. Else, I guess we can just do if again. We do the same thing in B, but this was incremented by self a len, right? So I guess we'll call this index of car. That seems reasonable. So then we can just look for this thing, right? We can search for the tag. So we should be able to say like buffered index of car. We look for this. If this is true, we're trying to basically like slice this thing up, right? So just consume that many bytes, I guess. Like self buff consume this many bytes. Else, we consume everything. Maybe this should be a little consume all. Self consume self buff len. Yeah. We consume everything and go again. Advance the tag. Yeah, sure. I think that we're going to have to get a little bit tricky here and start like I don't know if we want to kind of do everything at once here. It'd be nice to have like incremental progress. I don't really know how possible that is. And then also after we consume all, we have to populate. So we'll call this file vectored reader with f is equal to self file. Something like that. Something like that. I think that we could probably construct this. If we're tricky about how we use this thing, I think we can leverage the fact that Zig won't compile code that isn't used. So like I think this will actually build. Yeah. And XML lexer no longer takes in a reader, but will take in a file, which kind of makes me think this isn't a generic type anymore. Yeah, he's not. He is not. Because it's just now file is stood fs file. Because we are kind of handling the buffering ourselves now. Which means that we can do XML lexer with whatever we were supposed to pass in here, these things. Here we go. All right, so this stuff goes away. Cool. And now can we do like lexer advance to tag? This is the thing that we've implemented. So we should be able to do stood debug print token. Or something. I don't know. At the very least, this should compile, and we should see. Okay, 497. This doesn't fail, sure. Okay, so he's mad because expected U16 found U size. It's fair. It's fine for now. Consume all doesn't take arguments, that's true. And he's mad here because we do need to return something. So we need to return like how much we consumed. Which kind of means that our buffer needs to track how many bytes from the file he's ever read total. So num bytes read. And then every time we populate, we'll say this is this. And self num bytes read plus equals num read. Okay. I like this as bytes read a little better. Okay. And now when we generate our token from advanced tag, we can say like, okay, we started here. This is like num bytes read minus the length. I think. Which kind of makes me think this should be a function of this thing. He's going to have like consumed bytes. Which just returns this. Yeah, something like this. So we'll call this consumed bytes. And the end is this. And then we return a token that has these things in it. So it's I found a couple libs, but you know we like to hand roll around here. Yeah, it's not, the point is not to make something good or that needs to exist. The point is more fun, I guess. By some metric of fun. Okay, there we go. So we go start to end. All right, what's that give us? He does not compile. It's a hard life out here. Right, so this is probably mad because we wrote this as needing... I guess this can be reference as well. 230. This has to be intcast. Intcast. Start is expect type u32 found usize. We're kind of just like fucking up our types everywhere. But we'll just kind of intcast them away for now and then kind of note to ourselves that we should fix that later. So it's silly to have intcast all over the place when we write this thing for this one specific case. Index of scalar requires a type to be passed in to disambiguate, but when you're passing in arrays or slices. No field or function named len here at 261, right? Because this is not buff len, this is just self len. All right. So it looks like we got a token. Can we get a new line on this shit? So what happens here? He says start and end of this content type is 0, right? The first thing that we do when we get to the beginning of the file is we immediately see an existing tag. So we can test this by going here and like hitting some enters and spaces or something. And we should see that the content length changes. Instead, we get a parse error, which is surprising to me a lot, like very surprising to me. Whoa, what the fuck? Oh. That's actually in libxpad. Here we're doing exactly what we expected. So maybe the spec says that's not allowed, which is fair. Okay, cool. So advance to tag. 1 out of the way. What comes next in our function, our little next function here? He advance while white space. Okay. So this is gonna look similar. Where's our what did we just write? We just wrote advanced to tag. Okay, I'm gonna leave this open as a reference and go advanced while white space. And let's see if there's like some sort of commonality in this. There definitely is going to be, right? We're going to consume bytes until we find something that is not white space. Yeah, I think that makes sense. Right, so all of this is going to happen. The new version of this is not going to return anything because we don't need to worry about the fact that we consumed one extra byte like we used to. And here we just need to probably implement like index of many or of any or something. Right? And it's going to call whatever the like stud mem. Why isn't this auto-completing? Buffer pair. Here we go. So we were trying to do like stud mem index of any. Yeah, nice. So this is just the same thing as this. Right, and this is cars. Okay. Now, there's probably a fix me. Looks an awful lot like index of car. Not gonna lie. Not gonna lie. But that's okay. So now this is going to call index of any with stud ASCII white space. Cool. Cool. And then we'll do fix me. Looks a lot like advance to tag, was it? Yeah. Okay, so now we call advance while white space. And I guess we should see nothing, which is a little annoying. It's kind of annoying. So it's kind of hard to test this right now. I guess the next thing we have to do is try to actually parse the tag. Which is kind of all of this. Do we use like inbuff in this? We do. Self inbuff append. So we can just, what's going on here? We basically go byte by byte. We go byte by byte and we look for the first thing that matches only one of the possible prefixes. So we feed each of these prefix matchers byte by byte. We probably don't have to go byte by byte, but for now. And I think that we kind of have to do the same thing, where we like populate our circular buffer if we need to. Which kind of makes me think, I think kind of like overall, we're going to see ourselves doing this pattern a lot. I think we're going to see ourselves doing this a lot, where we basically follow the pattern of like, look for thing and then consume otherwise, right? And populate. Like this is going to happen a lot. Maybe? I guess if we have populated the buffer at this point, right, just like off rip, we call self buff populate, right? With file vector reader equals self file, right? At this point, we should have enough to identify the input token, the start, right? So we don't actually have to worry about it here. Okay. So maybe we look at like the current content. And we say we're going to have an API to pull 1 byte out of this. Yeah. So we'll call it like value or something. And he's gonna return a U8. Yeah. That makes sense. So if index is greater than self a.len, we return self b. I guess we'll do it this way. Less than or equal to less than a.len, we return self a at index, else b index minus self a.len. And I think we're doing this like fix me index x minus self a len is coming up a lot. Maybe a function b from idx, b like b index or something, right? We could do something like that. Something like that. Okay, so now in our next function, we're basically going to get the content, and we're going to say like for 0 to content len, we can do let's think for a second. I think it's more like this. I think it's more like this. So we get I as a usize, and we advance while whitespace, and then do this stuff, I guess. This needs some cleanup, but it's fine. So B is going to be content value at I. Okay. We'll call this prefix idx. Okay. So all of that looks kind of okay. We push this stuff, and if we once we find the right prefix, then we're chilling. Now this name append slice needs, the name of this thing is now going to need to, it's basically 0 to I. No. So at this point we found where the prefix value ends. Hand wavy. So if our prefix is just like the open tag, we have like a name here, then I is going to be pointing to the start of name. Okay. Okay. I almost feel like name should now be a buffer pair. That's kind of how it's feeling. Because, yeah, it's probably guaranteed essentially to be in this one content that we got out. So can we call I here like something a little bit more like content idx or something? We'll figure it out later. So our name is going to be like we're gonna have like name start is content IDEX. Content is overloaded as well. Content is an overloaded word. Well, that's fine. It's fine. Maybe we should call it like buff slice. Yeah, I kind of like that better. Buff slice. Which makes this buff slice IDX here. Okay. So the name start here is buff slice index. And then eventually, which I think actually means that we don't even need this shit cached. To be honest. Okay, here we go. Let me fucking read until white space or an end character. So we're gonna say like self what is it? Buff slice index of any. Okay, so first we need to slice this from name start onwards. So this is going to be the name slice or something. And we need to find name slice index of any, which is going to be white space or the close angle bracket. That's what we've done here. And so now name slice equals to name slice name end. Oh yeah, that's feeling kind of right, dude. That's feeling kind of correct. So can we pull this? It'll be easier to test if we had functions split up for this stuff, but maybe it's okay for us to just kind of do this for now. I guess we still need to go advance the end sequence as well. Okay, we'll skip attribute parsing here. And then we will say buff slice. Maybe. And then we're gonna search for the end sequence. So we need one more index of. We need one more, which is index of. What's the like mem thing? Yeah, it's like this. An index of. So this is going to be needle. And otherwise the same. Okay. So we're gonna find the end sequence. Buff slice index of and sequence. So we'll call this element end or something. I don't know. And then we say self buff consume. We can't consume it yet. We cannot consume it yet. So instead, we do something like. We'll figure it out in a second. What's our return look like? It's this. Okay, we'll return a token with a buffer pair in it for now. Name is name slice. What else is in here? Start is equal to. So I guess kind of at the start of this thing, we say that the start pause is self buff what was it? Consumed bytes or something? And then the end is also like this. We haven't implemented attribute parsing yet. I guess end pause is element end here because we haven't actually consumed anything yet. I think that makes sense. 553. He's mad because name here needs to be, I don't know, fuck it, undefined. I don't give a shit. Okay, that compiles. So what happens now if we call next? Error unit is ignored at 394. We had to write one of these in Java for my data structures class, bringing back memories of that. Nice. I'm having fun. It's definitely like a fun little exercise. 459. This needs to be a slice, not an array. Key needs to be a string, not a value, not a single byte. 431. He's mad at this slice needs to start somewhere, and this has to be, or else return error no name end. Okay, start pause. Fuck it, we intcast it here for now. Probably this is being intcast as well. We'll eventually come back for these intcasts, but I'm just trying to get somewhere. Element end or else return error no element end. We're kind of implicitly saying that we can't have an element that's greater than 4,000 or like 4,096 bytes long. And I think that's fine for now. Missing field type. All right. So he gets mad immediately. No address available. What is happening here? XML parser debug print on the token. Okay. Can we GDB here instead? So name is completely invalid. Right, because we initially advanced till white space or something. Yeah, so this is fucked. So this has to be like we kind of have the same problem here where this thing actually needs to not consume the data. Well, I guess nothing here is actually being used, so it's fine. We just do A is equal to this, and B is equal to this. Because the advanced tag is not actually returning any relevant data, just the start and end. It's actually fine. There we go. Okay. So first next call looking good. And then let's just do another one. It looks like he's not fucking advancing. I think that's because we didn't implement advance at the end of this, to be honest. I think we just need like self, buff, consume, element end. But kind of on the next iteration. So it kind of can say like here, like to consume. I guess technically you don't need this. Technically, the memory will be valid in the circular buffer until you read again, even though the pointer is moved. So maybe we will exploit that. And we'll say, note, we are returning references to things in buff, which makes this consume look sketchy as fuck. Look sketchy. However, the data in the buffer will not be overwritten until the next call to populate, which should not happen until the user calls next again. Okay. Seems reasonable to me. Seems reasonable to me. He actually still doesn't consume though, which is kind of crazy. I guess this advanced to tag was supposed to set populating tag or parsing tag equals true. There we go. Wait, that's actually good. That's looking real promising. Real promising. Now, I guess we should probably be able to look at the data in here. So I wonder if instead of like start and end, maybe we also return the content. The thing is, like, sometimes the content might be more than a page if you have like a tag than like a bunch of shit. Which makes this hard to validate. Makes it hard to validate. We could kind of like use our what's pread do? Does this like move the cursor? I'm not sure. It would be nice to actually like see the fucking data that we're printing, that we're looking at, you know? You know? Once we get this working, I'm curious to see if it's faster now that we're using readv and all. Yeah, it'll be curious. It'll be interesting. I guess we won't really have like a nice comparison because I don't know if we have like a nice checkpoint to read from. I guess we do. We could probably look from here or something and compare. I think that it probably won't because before we were using like a buffered reader, so I think the buffered reader is probably already doing the right thing under the hood. But it will be interesting. Here's what we'll do. Here's what we'll do. Read to end Alec. Oh, interesting. There's a read v all in here, which we could have used. But we'll come back to that. So we'll defer data, Alec free data. Boom. Okay. And now we should be able to look at we can look at like the data at data token start token end, right? And we just have to make sure that before we do this, we like f seek to 0 after doing this, so that the lexer starts in the right spot. Let's see what that does. Okay, so this looks good. This does not look good. 64 to 78, so that is the size of this. Why is it the wrong way around? I guess we should do 4, 0 to 4 here. And then down here, kind of clear this stuff out for a second. Oh, I see. So this thing consumed way too many characters. Way too many. That's the problem. He was only supposed to go to here. Okay. Good clue. So here we say I just want to flip this for a second. Okay. Okay, so that's kind of interesting. So if we start without advance to tag, then it's fine. Confusingly. Okay, where should we start logging here? Here we have our start pause is clearly 0 at this point, because it says 0 here. And 60. So that's kind of the interesting thing here. Is the end position is the index of the end sequence given buff slice. Okay, so did we fuck up index of any? Seems kind of hard to fuck up here. Can we look at like what is the end sequence? What is it looking for? Oops, down here. Okay, so he's matching the wrong thing here. He should be matching open XML, but instead he's matching this. So what's happening there? So we never end up in here, I guess? Probably. Like our token type is probably still element. What is this? Something name? Tag name? Yeah, I think it's this. Yeah, so we're seeing element, even though we're pretty... Yeah, in fact, we see this here. I could have just read this. Even though this should be matching XML. So what's happening there? Oh, because we're not calling advance anymore, which reset the prefixes before. I see. Sure. So what else did we do in that? We cleared the in buff, which doesn't happen anymore. We set up our return type, and then we flip parsing tag. Sure, so we'll say like amount here. Which means that we can call self advance element n like this. And then this stuff goes into advance. Kind of like here. And I guess this doesn't really belong here anymore. Yeah, that feels good. That feels good. Something like that. Something like that. Something like that. So still not good though. But I think it's also because we were supposed to reset prefixes off rip, which we did. So that's actually not the problem. So are we like just never matching? Can we do like checking byte? And then we put the byte here, and then can we say print matched and not matched and feeding. All right, let's start there. Let's just kind of work our way forwards again. So we get content. Then we don't run this shit at all? Why? I mean, that just means that I fucked this up. Like, std debug, can we break here? Yeah, it's just completely uninitialized. Why? What the fuck? Oh, because I'm fucking not calling init on this thing anymore. God damn it. Okay, I see. I see. Because we used to initialize in here. My bad, my bad, my bad, my bad. So this gets our allocator and file. There we go. And then I guess what we do here to prevent somebody from accidentally doing this again is we make prefix list something that is not default valued. And we say prefixes equal to it here, and then reset prefixes here. And then our lexer we now call XML lexer init with our alloc and file. And presumably this has to be tried because we have an allocation happening on reset prefixes. Okay, so now we have, at the very least he's doing something. Checking byte S, not a match, not a match. So S seems wrong. S seems like the wrong byte to check here. Because it seems like we should be looking at the very beginning of this. So somehow we ended up like consuming some bytes to an S or something. Which is very confusing. Hi bro, do you work anywhere? Not right now. Right now, I am deciding to play around on Twitch. It's a much more satisfying way for me right now to live. It turns out work can kind of be stressful sometimes. And it turns out just not working, not that stressful. Who could have thought? Who would have seen it coming? So we're doing this for now. Until either, probably I guess until I feel like I need money again. Is probably the end state here. But maybe we make enough money from Twitch that it's fine. Speaking of, sorry, Sam Janwich, I completely missed your Prime. Thank you for the Prime. Appreciate it very much. How do you make money? I get that you have fun on Twitch. What do you used to do? I used to work in software. And I will again probably someday. But I mean, like, as a software developer, if you just I feel like everyone tells me that I have like a pretty unique take on contentment, I guess. Like, I'm so much like, I just don't want stuff really, right? And so like that kind of allows me to just live this life where I've been making software developer salary and like arguing with my bosses to get like valued in some way, right? Like pushing for reasonable-ish wages, but not spending the money. So I have like 10 years of savings that I can burn through for a little bit. Which I'm very fortunate to have. Very fortunate to have. What are your main expertise interests? I like coding. Which is part of the reason why I actually quit my job is because like I wasn't coding enough, and then the coding I was doing was stressful, and then I didn't have like the energy to come home and do more coding that I wanted to do. So that's kind of where this lives. I like video games. I think that's it. I'm very one-track mind. uh Expertise? I don't know. I just do stuff. Maybe you can find a job where you can actually stream the work. E.g., Mike Conley streams while working on Firefox. Yeah, that seems like that seems pretty sick. Although it would bring some of the stress back, but that would be pretty cool. That would definitely. I hadn't considered that at all. I mean, like which field, low level, system programming, web, etc. Okay, so I did a lot of. I mean, I don't have like a ton of experience. I guess like I've been coding for a long time, but like employment probably like 8-ish years. I don't really remember. A lot of that was in like camera firmware. So I worked at this company that we made like security cameras. They give you a board and they say like what make run Linux please and transfer data to network. So I did a lot of that. And then I did some like work at like this like AI company where we worked on like training of neural networks to find things in 3D space given to cameras type shit. Both jobs extremely fun. Both I would say are probably on fairly low level. My web dev is like pretty shit. My C++ is decent. My Python's okay. I think my cell is often I can at the very least, even if my experience is shit, I'll figure it out eventually. So yeah, that's my life. What am I doing here? What the fuck am I doing? I can't remember. Right, we are still for some reason not matching the correct token type here because of the S at the beginning. If you don't mind me asking, how old are you? What year is it? 2024? 2025? 2024. Which makes me 31. 31. Okay, so why the fuck are we seeing that S there? Makes this kind of seem kind of wrong. Makes this seem kind of wrong, which makes this kind of interesting. Yeah, something about this doesn't feel right. Buff slice comes from the buffer content, which always goes from the read pause to the A end and then the 0 to the B end. And so we're seeing an S at A0? I guess we should just print out the buff slice. Okay, what am I doing here? So P buff slice. Where the fuck am I? Did we sig build? Okay. GDB. B here, run. Where the fuck am I? Yeah, so here I should have buff slice here. Okay. So here we have a buff slice of A4096 B0 that does start with an S. And it looks like he's like 4096 into. We're like 4096 bytes into the data, probably. Would be my guess here, is that we accidentally paged too much in. So can we do like a head Is it like tail? How do you like skip bytes? Output the last, or use C plus num to output starting with byte num. So tail dash C plus 4096 res Wayland. And then head dash N like 50. 10. Yeah, so we're getting one page in by mistake. So probably when we populate, we probably are fucking up checking here the length. If self-len, because probably what's happening here is we are doing right pause % here. And this is ending up reading the whole buffer again because we're not doing any check for how much we can take. Yeah, so we can say if self len is equal to self buff len, return a empty thing. Yeah, and this just be like boom, boom. Okay, let's see what happens there. So now we have panic unreachable code at read vectored. I see. So probably on our vectored read, we need to handle 0 size buffer. So here we need to do like if buff pair len is equal to 0, return 0. Okay, that's looking better. And we still turned out to be an element here. But now we're checking the byte of angle bracket, which actually seems correct. Now this double not a match thing is fucked now. Which is kind of confusing, to be honest. Oh, maybe that's fine, actually. No. What the fuck? Yeah, because we should see matched. Shouldn't we? What are our prefixes? Yeah, this has question mark. Oh, these now have to be like this. I see. Nice. Okay. So now we have our first type is still an element. Why? Why? Can we log which one of these things? Prefix dot string here. Like, what's going on here? So we feed this, check this. This is not a match. This is not a match, but the other one never finished matching. Kind of seems like. So we should say it should be while greater than 0 here. That was a mistake from yesterday, I guess. So here we have checking byte this, feeding, checking byte this, feeding not a match, checking byte X, feeding L, XML matched. Okay, there we go. So now we have correctly identified ourselves as an XML decal again, and we are going to the end of this thing, which is really good, really good. Now it seems like we need to go one farther on the end. Element end, I guess, is the index of the end sequence. And then we need to add. We need to add the the size, the length of the end sequence. So that should be a lot better. So now we got this. That's pretty good. Which is end 38. Now what's confusing here now is that we end up at start 43 on the next iteration, which is a problem. But at the very least, we got the first line working again. Twitch figured I wanted 2x 30 seconds of idiot commercial after watching for 7 minutes. I mean, come on, they'd be sabotaging. Yeah, I think what happens here is that I have to turn on. So I think pre-rolls are the thing that piss me off the most on Twitch. Often I'll like open Twitch and I'll click on a stream and it'll like pre-roll me and like it will like bug out and I'll like get to the stream and it'll immediately start to pre-roll again because it doesn't really realize that I watched them. And so I'll get like pissed off Twitch streams and I get hit with another pre-roll and I just get hit with pre-roll after pre-roll after pre-roll after pre-roll. So that pisses me off enough that I like leave Twitch a lot because of it. So what I have to do is to disable pre-rolls, I have to run ads. So I just run a 3-minute ad every hour, which I guess means that even if you just got here, you get the ad at the same time as everyone else. I kind of wish that you could give like each user something. Yeah, I don't know. It sucks. It sucks. But what you gonna do? Like the alternative is worse. If that makes sense. Okay, so I think that this feeding code is like matching code is working correctly. So we can kind of like delete some of these prints just to like pretty up our output a little bit. And now the trick is, why the fuck does this start at 43? Like, that's not what should happen. Turbo, maybe? Yeah, maybe that's the way. It's probably in here. Advancing to tag. Probably what's happening there. Yeah, so something here is happening where it's failing probably if the tag is immediately there. It's probably skipping an entire tag. Although it kind of seems like this should just give me the start like 0, 0. Okay, so we're kind of here. So our start here is 43 already, which is not good. Yeah, okay, I can see what's happening here. So the question is, why is this consumed bytes returning 43? Oh, because we have to consume. Don't we consume element end? Yeah, it seems like we should be fine. So you have read pause plus equals amount, which means that length shrinks as we read more. Oh, that's a little confusing. It feels like we're consuming too much. I will give it that. Right, so we have the first thing. It says that it ends at 38. Let's see if that's right. Yeah, that seems right. Seems right. I think that the tail is 1 indexed, so it's 1 more or something. Yeah, so if we're at here, well, that's right. So then the question is how come consuming here is taking up more than that? Did we consume earlier by mistake? We advance while white space, which might consume. It does. So maybe we just have to make sure that we take the buff slice after there's no more consuming. So we'll put like a node. Do not consume anything between here and end of function. That's very important. Very important. So what happens now? We see oh, this might look okay. Hold on. So we try to end 33. And then start 5 and 33. That doesn't seem right. Oh, I guess it is if we don't consider like the beginning of the tag here. Which is why we moved it back here before. So I guess here what we should do is this advanced while white space actually wants to act on the buff slice, not on the reader. Aha, yes, yes, yes. So this is going to work on slice. I think. Where else is this used? Yeah, that looks like it will be fine for now. So here we can return a new buffer pair, I think. And we return, we basically don't have a while loop anymore. And here we return self buff. I guess we just want like white space end is kind of actually what we're looking for here. Which means that we can return just this. Kind of feels like that's the play. So it's like a white space end on the buff slice. Okay. And this is going to be the like prefix slice, I guess. Yeah. So this is like after the open tag, we're gonna have like XML question mark, right? We're trying to start like find this, which you could write like this, I think, is like what we think here. I actually think that's not legal. Let's look at the XML spec. Ideally you take a break when you run ads. Yeah, I mean ideally, but I don't want to break flow every time Twitch just says you have to run an ad. It's fucking annoying. So, it is what it is. It actually looks like the prologue XML decal, like it needs to start with this. So it seems like arbitrary white space after this is probably not allowed, so we can kind of probably just skip this. Seems like that'll work. So now we go 0 to 38. We get this. Then we see start index 39 is larger than end index 25 at token start to token end. That's not good. That's not good at all. How is that happening? 39 to 25? Yeah, something's fucked here. So where is that calculated? Element end is the index of the end sequence from buff slice. Oh, yes, this has to be start pause plus element end. Oops. There we go. Hell yeah, dude. Hell yeah, we're so back. We're so back. So let's go like 50 of these. And let's try to reduce the spam here. So that looks like it's like kind of working. So we get like nothing, then we parse the first line. We parse like a new line. We go, we now have an element. We have some content. We have an element, content, element, copyright, content. Here's the copyright message. Then we get the element end for copyright. Looking pretty good. Looking pretty good. All right. Checkpoint. So what have we done? We've actually made like a lot of progress. We had we implemented this like circular buffer reader thing that does vectored reads from a file as it moves forwards. He generates this like buffer pair concept, which is basically like when you have a circular buffer, you don't necessarily have like one contiguous chunk of memory to work with. And then we implemented a bunch of like parsing around this buffer pair type, which is pretty sick. I think that what we could do maybe. I don't remember. Oh, right. If we want to print like the name and stuff that comes out of this thing, we need to. I want to like implement like a format for the buffer pair, so that we can like kind of serialize this thing together, which should be pretty easy. It should just be like if we go into like stud, format, this will tell us we implement a function with this. And the value is a buffer pair. And all we have to do here is do like writer print A. And B. Yeah. So this is going to be self here. And then we just ignore the things that we're ignoring. Yeah, that's fine. I guess we could do something like... That's fine, it's fine. So now we should be able to do like token name here. And that should actually give us the name, right? I think. Did I print something sane there? Let's write the name here. And let's like color it or something. I think it's like this. Let's make it bold as well, and then reset the formatting. I think it's something like that. There we go. So it is sometimes missing the first character, which is a little annoying. A little bit annoying. But at the very least, our formatting is maybe working, right? So name is coming from name slice, which comes from the buffer slice name start, which is coming from buff slice IDX, which gets incremented here at the end, which is a problem. So we'll do -1 here. Is that better? I see. And then we need to make sure that if we need to like increment it by the matched token length here. Right. So here we'll say like var token len is every time we do this, we say token len is equal to prefix string len here. And then we say plus token len here. I think that'll do what I want. Feels off again. Yeah, because I'm an idiot, I guess. I don't know why I thought I'd do that, because we are incrementing this as we go. Oh, right, we're trying to get rid of this slash here. So why is the slash there sometimes not others? If we are incrementing the buff slice index every time we look at anything. Oh, my bad. We do, that does make sense. And instead of using buff slice IDX, we just use token line here. In which case we can kind of just use name start instead. Which makes a lot of sense. Makes a lot of sense. There we go. Because here he needs to start at 1 by default. Right, because the unchecked prefix is just like an open angle bracket. That's looking pretty good now. That's looking pretty good. So we've extracted the name and the name again, and now we just have to start appending the last piece that to get back to where we were yesterday is what is it? Attributes. Attributes. So how do we want to do this? We kind of want to say like attribute slice is the name slice. Kind of like ends up like here. Yeah, it's like something like this. There we go. And then we're going to be able to like do something with the attributes list. I just don't know what yet. I guess we'll kind of like look at what we did before and try to like adjust it. So I think it's going to be something like attribute slice comes in here. And we were doing all sorts of crazy shit before. So this definitely needs some cleanup, Jesus Christ. But I think we want to incrementally improve. So anything that was doing ends with before, this needs to do it on the buffer pair that we pass in. Does it? I think what we were doing is we were kind of like pushing byte by byte into this thing, which is probably no longer how we want to do this. We probably want to like, we want to do like attribute end. Yeah, we want to do something that's like, index of the end sequence. Yeah. It's gonna look something like this. So this is gonna slice from the 0 to the attribute slice end. This again, all this code needs to get better. This needs to get better. This is a disaster. What's going on here? It's really hard to follow. But we will get there. We will get there. I guess we kind of want to do maybe attribute slice. Like this. And then pass it as a pointer is kind of how I'm feeling right now. So this guy can kind of like re-slice him if every time he consumes one thing. I believe that we no longer need to look for the end sequence here because that's kind of been covered externally now. So this can kind of go away. Yeah, so it just kind of like looks like this now. And now he doesn't have to worry about looking for the end sequence anywhere, which is super sick. This advanced while white space, I think already white space and attribute slice. So here we say attribute slice is equal to attribute slice slice 0 to the white space end. Or else 0, I guess. Yeah, if it doesn't find... I guess it's actually or else attribute slice len here. So this will discard any white space at the start of the attribute section. It should. Then what happens here? Sorry, I'm thinking. Okay, yeah, okay. So this gives us something sane. So the key start is now at this position. So instead of working with key start here, we'll say const key slice is the attribute slice at this point. Yes. And then we just have to slice, we have to set the end position. Which means that we need to search for an equals or white space. Yes. So we're basically looking for index of any is kind of the opposite of what we want. Is there like a index not of many? Index of any? Like I kind of want like last index of any. Find the last index of a subslice, searching from the end backwards. That's not really what I want. I want to go like, give me the last thing that isn't one of these things. Find the first item that is not contained in the values. That's what we want. Index of non-pause. Yeah. Yeah. So which means that our buffer pair, we need to implement index of none. Bars. Index of none. All right. Which will have to get cleaned up. We will need to duplicate, but for now we can say key end is equal to key slice index of none given this. Right, so the first thing where none of these are true. Or else, if it doesn't find it, we have like a fucking problem. We'll say return. No, wait, this is index of any. Yeah, sorry, we're looking for white space or an equals. And if we don't find it, then we return an error. No key end. I feel like it's going to make sense here. So then we have key slice is equal to key slice slice key end. But then before we do that, we have the val slice is equal to key slice. Sliced from key end onwards. Yeah. I'm just gonna put fixing on this and like this pattern needs a like an API or something. Okay. So we're basically now, we want to do the same thing where this is where we do the index of none. Val start comes from this, right? So we pass all white space and equals until we start seeing like a quote is basically the next thing we should see. So then we can do like assert here. I guess we are looking. Like to do this correctly, we kind of want to advance while we see white space. Which means that we have the key slice value at EQ start, or equal index, I guess. And at that point, then we should be like, hey, we got a fucking equals. And we should call this no equal. Then we advance white space again. Yes. Yes, yes, yes. And I think like this, all this re-slicing stuff is kind of making this harder. I'm not gonna lie. I think we just want to do this. Start index. I feel like that makes our lives a lot easier. Oh, but then we have to fucking check the start index as well. Right, so this is self alien. Yeah. Fine, we'll keep doing it this way for now. But I do think that re-slicing is probably not the way. It's probably easier to just keep like one index relative to the start of the slice. But we'll see. Okay, what happens now? Attribute does not have equals. Okay, and I guess we could actually print out val slice here. Okay. So I guess now, once we finish the equals, we have val slice is a reslice of itself. Yeah. Something like this, where we go from like one pass where the equal sign is onwards, and then we do an advanced white space again. So we keep going now. Where we should see val start comes from this. Right? Where there's no white space, no val start. And then here we assume that the value should start with a quotation mark. That's important according to the specification. So val slice value val start. We are assuming that this is equal to this. Then we can reslice again. Val slice slice val start plus 1 val slice len. Okay. And we try to find a quote. So we say a val end is going to be val slice index of scalar, and we are looking for the quote. Or else return error, no malformed attribute with attribute value does not end with a quotation mark. Okay, so now our attributes don't have like these anymore. These are now just buffer pairs, which are references to our circular buffer. And this we just say like key slice and val slice. And we reslice val again from 0 to val end, I guess. Okay. I mean, there's like a chance. There's a chance. I'm not 100% sure here, but you know. Attribute, slice, end. We can debug as we go now. Or else, return error. No. And sequence. Yeah, this is kind of stupid. Duplicated with above, but it's fine for now. I think it's correct, just like stupid. Okay, and then this needs to be dot star here. Index of none does not exist. Really? Oh, because I changed the name here by mistake. Okay. 540. We need these index of none. These need to be ampersanded to turn them into slices. Okay. No field remember called index of scalar in buffer pair. Really? Do you just call it index of? Oh, we call it index of car. Stupid. We should use the right name. 568. We tried to reslice by calling slice. And index of non-pause. Expected 4 arguments found free. Oops, I left this as well. Oops. Okay. No key end. No key end. Let's take a look-sees. What the fuck? Why am I not breakpointing there? Hello? What the fuck? That's annoying. Well, I guess we'll breakpoint on the line before. All right. We look at slice here. What's in here? B is invalid memory with length of 0. I guess that makes sense. So here we have, we're looking for white space or equals. What is our length here? Length 0. A length and B length are both 0, which is a problem for sure. For sure. Interesting. Interesting. So how did my A length get to be 0 at that point? I guess we probably also want to look at the attribute slice this came in. Break here, run. Let's take a little peek ski at this guy. So his length also 0. That's a problem. That's a problem. Attribute slice end 17. Okay. So name slice is 13 long. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh. It thinks this is the name. Okay, hold on. Oh, but that's probably fine, actually. I guess, like, there's something stupid happening here. But hold on. So name slice. This comes from name start, which comes at the end of the prefix. Okay. Then the name end comes here, and the attribute slice is actually set here. So I'm actually interested in, like, getting to right here. So right now, the name slice has a really, really, really long length. That's good. Which means that the attribute slice also has a really long thing. Now, we have to fix this consumption of version here. That's a bug. But otherwise, this looks okay. So can we look at P attribute slice end here? 17. So that kind of also makes sense. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, the backslashes aren't part of this. So I think that's fine. It should get encoding UTF-8 here. Okay. And then we have no key end. Okay. GDB, break here. Oopsies, break here. Run. Okay, so this is the first. We should see element in here, right? Info args, P attribute slice. Yeah, so we have encoding here, length 0. So why the fuck is the length 0 now? Somewhere between where we got into this function and after, we have a problem. So it's slicing to the white space end. Oh. I just had it backwards. Oopsies. Oopsies. Got EQE. So he thinks when he's looking for equals that he's got the letter E, which is a mistake. Because he tried to consume. That's confusing. Can we print out everything that we have before? So this is the key length, key and the value probably. Key slice, val slice is probably what we're looking at here. Key slice is nothing. Value slice has encoding UTF-8. I see. So why didn't this consume white space here? Oh, it's because I wrote index of any here. It's a bug. Okay, there we go. So got EQ equals encoding equals UTF-8. Okay, so that's looking good. Now we actually have to make sure our output gets moved forwards by the correct amount, which is not trivial with the way that we've constructed this problem, because we're reslicing over and over again. Maybe that's actually fine. been wrong, I've been down. Dun. Let's think here. So we have a key slice and a value slice. Key slice and value slice. This thing needs to get advanced by that amount. Yeah, it's definitely not trivial with the way we've constructed this, which is fucking stupid. Definitely fucking stupid. Alright. So let's just try to avoid reslicing this stuff all over the place. We want, like, key start is equal to 0. I guess we want to do actually, like, key start is equal to this. Then we want to give index of any pause. And this comes from the attribute slice. Given this key start, okay? Index of any. So we want to do index of any pause. So these are going to be if start is greater than self a len, we kind of do what we were doing before, but we need to use like the start here and start minus self a len here. Okay. Else, I guess we just have the simple case of doing B only. I think. Okay, and I think it's time to start trying to like deduplicate some of this shit. So we'll do like a function run index of. I don't know if it's easy to make like a generic function that calls another function like this. Run index of pause. Yeah, I think that'll work. So we'll have like a start here and then a val calls needle or something, and this will be any type. And this will basically do what we did here, but we also take a function here. So then we will run the function with needle, and we'll just do it like this. So now index of any pause can call like run index of pause with self start cars and stood mem index of any pause. I hope that works. And then can we just like comment all this out for a second? I just want to see if that compiles. I just want to see if that compiles. I think it's fair. We probably have to return this. Nice. Yeah, that compiles. Sick. All right. So now we can kind of implement the rest of this in terms of without reslicing, which was causing us all sorts of pain. So now this just becomes val start is equal to key end. I guess that's probably not true. Here we're going index of non-pause on the attribute slice again. which means that we need an index of none pause. Which should just work, which is cool. All right. I don't know, we'll figure that out later. We'll figure out improved logs in the future. So now we say that the val start, here we actually need to pass in the key end here. So now val start is the EQ index plus 1, except this again is not the val start. This is the quote start. Let's see. Quote start comes from the EQ index from the attribute slice again. Yeah. This is starting to feel a lot better. A lot better. So we consume white space until here. And then we just want to make sure that the attribute slice quote start is the right thing. Okay. Chillin'. So once we have the quote start, now we know where the val start is. This is attribute, this is just the quote start plus 1. Okay, attribute slice index of car pause, which we need to implement. Index of car pause, and this is car. Index of scalar pause. Okay. Fix me escaped quote. It's not implemented here, but it's fine. And then we can return here the attribute slice from key start to key end. And the same thing here, but with val start to val end. There we go, baby. Now we can do attribute slice is equal to attribute slice key val end plus 1 attribute slice.len. Okay, I think that's a lot better. Attribute does not start with a quote is now the problem we're seeing, so does not start with a. So can we print out like I guess we want to do attribute sliced from quote start to attribute slice len. I guess that's kind of what we want to print here. Okay, so this attribute does not start with a quote, and we say equals UTF-8. So we probably just forgot to add 1 after the equals. Yeah, we did. Cool. Now we're doing index out of bounds on key start to key end. So index 9 len 0. Because we do this in the wrong spot. This is to be deferred. Okay. Error, no key end. So what's going on here? We literally cannot find anything in here. I guess if there's no key end, that kind of means that we're likely not parsing an attribute. I guess what we should do here is, can we, I assume that this is like some edge case where like the length of the attribute is 0. Can I breakpoint on this and run it? And then, yeah, so here we have start and 0. Start and end are both 0. So we just have to do if attribute slice len is equal to 0, return null. Much better. All right. That's maybe looking promising. This is a bug, but we'll ignore that one for now because it's not actually important. So now can we try to like print out the attributes that we got? So let's change the color. And then for token attributes, can we print out what we get? So this will get a little s equals s here. So protocol, we don't see any attributes there, which is a problem. But I think that we may have forgot to assign them. Yeah, we did. I think we did. Okay, wait, that's looking like maybe promising. Let's see. So we have description, summary equals. So it looks like it's only, oh, sorry, wrong one. So protocol, we have name equals Wayland, which is correct. We have interface, WL display version 1, nice. Attribute summary core global object, looking good. Attribute name sync. That's looking pretty good. Looking pretty good. So I guess, what do I want to do next? Like git add -u, git commit -m smile. So we're definitely crashing here on run index of pause. Right, this is just problematic. So this should be from 0 on B. Not from start. Yeah. And I assume index of pause. I'm actually not sure. Does he return I from start index? Yeah, okay. So he returns it relative to the start of the buffer that we're working with. Cool. Okay, so we're still seeing this in run index of pause at... Did I just fix that? Oh. This is a less than... Yeah, wait. How is this not okay? Oh, here. We need to return null. There we go. Yeah. There we go. Better. Now we're seeing no key end. How many characters is this file that we're parsing? A lot more than 2228. So there's just some case that we're not handling here. Some case that we are not handling. Oh, fuck. Oh, that's annoying. Okay. What have we got here? Attribute slice. So here we have some like 98 characters. He's saying no key end. So where's like a key start? So here we have 5 key start 5. 0, 1, 2, 3, 4, 5. That makes sense. Key end 5 does not make sense. Oh, but we also have to say, it also says no key end. So 5, which is a type, and then he's scanning forwards to an equals. I don't actually understand why this would be any different than any other problems. Oh, it's because it's not. Where was our bug at then? I thought it was at 2228. Oh, I'm just an idiot. Oh, great. It'd be nice to be able to breakpoint here without it sucking. So can we do this? Key end opt. If key end opt is equal to null, const key end is equal to key end opt. I assume that this will make it easier to breakpoint on the right spot. I assume. There we go. Yep. That's much better. Okay, key start is 0. Attribute, what's it called? Info args, p attribute slice. Let's dereference that shit. And so here is what we are looking at here. So our attribute slice is at the end of the sequence, and the length is 1, which seems wrong. It seems like the length should be 0. Can we, like, what's around here? P. Oh. I see. So this is a self-closing tag. This is probably the first self-closing tag that we're seeing. Check circular buffer len. It doesn't consider end less than start. It does. That can't happen. Is why. Circular buff reader. This is correct because write pause can be in the range of like 0 to 2 times len. I did that intentionally so that I could represent this way. And then everywhere where I try to index with write pause, I do write pause %len, essentially. Okay, so we're not handling the fact that self-closing tags might exist. Well, the attributes, right, because element end looks for this. I see. So we need to look for either, we need to look for the first of slash this or this. Huh. Or for now, we can just say, in some cases, parent calling code does not clip the end of a self-closing tag, resulting in a key that looks like it ends, like it does not, like it has a name of this with no key end. So we'll say workaround return null. There we go. That's looking pretty good. That's looking pretty good. So can we do like while true here and make it to the all the way to the end of the file? Looks like we're hot looping on something at the end. Here, this advanced to tag does not handle the case here where probably it's like if buffered len is equal to 0, we should return null here. And then here we'll say this. And then while lexer next gives us a token, we do this loop. Which he didn't like there. He's immediately returning null. Probably because we want to populate here. I think that makes sense. There we go. We are chilling. Big chilling. We make it to the end of the file, and we get all of our attributes. We are back to where we started 3 hours ago. But now what we have is much nicer. Much nicer. Well, not much nicer. It's a little nicer. We're starting to like pull out some like lower level abstractions, which is nice. We have our circular buff reader, which kind of looks like he's doing what I expect him to do. We have our vectored readers that are looking like they're doing what we're supposed to do. This like buffer pair thing. I would like to kind of migrate our next function here to use kind of hard indexes everywhere instead of like reslicing. Oopsies. Let's checkpoint. And then I also want to pull out this code here that resolves the token type. That needs to get pulled out. It's too much. And then, like, what is some of this code like completely unused now? This is unused, which is nice. This is used. This is used. Okay. This is also used. Okay, cool. So what am I trying to do? I'm trying to say like resolve token type. So it's kind of like all of this stuff. I guess for now we'll kind of do something like return a token type here. And then we'll just kind of figure out what our inputs need to be. Looks like we have self prefixes. I'm also not really convinced that self prefixes needs to exist. Because I think that we kind of like reset this prefix list on every iteration. So let's do it that way. So that kind of means that we don't have pass in here, and then we just have here like var prefixes is a std array list of prefixes. That's a prefix list. But we do need an allocator pass in here, which I guess is also probably not true as well. But it is for now. This is necessary, and then we say reset prefixes. Okay. We do need buff slice pass in here. That makes sense. And we probably do need to defer prefixes being it here. So this is token buff slice. Okay. Some selfs are removed here. And then we should just be able to return name, start, and token type. So here we'll have type, as well as the token end, or the prefix end, which means this should be kind of more like a parse element prefix. That kind of feels right to me. Parsed element prefix. And this should be parse element prefix. Did I say elephant prefix there? I feel like I did. Oh, which is pretty funny. And then here we just return type is equal to token type, and prefix end is equal to name start. Okay. Oh, fuck. I think I renamed that in a bunch of space I didn't want to. Here and here. There we go. Okay. Sure. Which means that now we can have this as like parse prefix equal to parse element prefix. Okay. Then we have name start is equal to prefix end. And then we need to do these same things where we migrate to using the position-based things. So we're going to buff slice index of any pause with name start, gives us name end. And then we have attribute slice is buff slice from name start, name end. No. Sorry. Name end to buff slice line here. I'm okay with this one because this is kind of acting as like an iterator. Eventually. Okay. Attribute slice end is index of pause, which needs to be implemented. So this is index of not any, but index of pause. Takes in start as well as needle, which means we pass needle here and we get index of pause here. Boom. Okay. So we find the end sequence, and then the attribute slice now is the buff slice from name end to attribute slice end. Nice. Nice, nice, nice. And then the rest of this kind of comes for free. We need to advance prefix token type. Now this element end doesn't need to be actually recalculated, which is nice. And this is prefix type now. Name slice needs to be sliced. This is a buff slice from name start to name end. And now he's mad at a bunch of stuff. So index of pause. True. So this comes from name end, I guess. I think. Token type is wrong. This is just type now. And then prefixes does not exist anymore. True. This is not used. Okay, I think that's fine now. 501. Prefix list can now be managed. Reset prefixes now doesn't need to take in an allocator to do this because it is embedded. And 503, we can write try here. There we go. What else is happening now? Reset prefixes is mad because probably this couldn't fail before, but now it can. Which is fine. It won't ever actually fail. Prefix end is the wrong type. All right, use that 0. That's fine. It's fine. This doesn't have to happen anymore because we removed that. Much better. Sick. He doesn't. I don't like that the end here is not containing everything. So we forgot that we need element end plus end sequence.len here. We forgot. All right, feeling pretty good. Feeling pretty good. Okay, let's try to get rid of any prints here that are non-essential. Okay, so I'm concerned that our content here is not right. So let's say that the content type is a string here. Tag name here. Okay, so here when we have content type content, I think that we are getting like the end bracket from the previous thing in here, which is a problem. Which kind of makes me think that we're maybe just consuming like a little bit too little. Probably on find tag start. Advance to tag. It's probably here that our end position is just like one too few. No, it's at the start of this. So at the start, we're looking at consumed bytes. So it means that when we advance and we consume bytes, this amount is off by 1. Oh. We want to consume the end pieces as well. Although that seems to have broken stuff. Oh, wait, maybe not. Oh, yeah, here we go. Content type content, name content. Description is an element end, which looks like this. Content is nothing. Element end. Right. Sick. Sick. We're starting to look really good here. Starting to look really good. Okay. What else? What else do I want to do here? Is I want to only return here. I kind of want to run this in a loop when we try to get the next thing, just so that if advance to tag returns a thing that's 0 length, then we can continue on. So we'll say ret is equal to self advance to tag, or else return null. If ret start equals ret end, continue. So that should get rid of all of these iterations that are just like useless. So now we only have content that has new lines, which I guess already existed. So this doesn't actually solve anything. But maybe it's fine. Maybe it's fine. All right, so I was supposed to do something else today, but we kind of spent a lot of time cleaning up, and I'm not even really done, I feel like, to be honest. So I don't really know what that means. I guess we can go for a little bit longer, but then I think that we will not do the mainstream today, I guess, because we just didn't get there. Oopsies. So I think that it's likely that a lot of these functions that we implemented here before probably aren't used anymore because we used the like pause based ones instead. White space, and we can just do it this way. Okay. That gets rid of this. Still chilling. And then I guess we can also get rid of this index of car1. by here not reslicing all the time. So here we do like, actually that's fine. That's fine. This might be a little silly to do it this way, but whatever. Whatever. Okay. What else? What else? What else? We'll get this way. I guess this is a lot nicer, to be honest. Like, how did this look before? How did this look before? Like, the actual implementation here was a lot more, like, involved, I feel like. Can we just look at, like, before? Or A only, I mean. Yeah, so this is what it looked like before. After it looks, I'd say that's way better. Populate the thing. We try to advance. Yeah, I guess we're not handling the part where content might be really, really long. Oh no, we are handling that. That's already in here. So we're chilling. Oh yeah, I'll take that. I'll take that. You know what? I think we call it there for the day. I think there's probably some more cleanup that I'd like to do a little bit, but for the most part, it's looking a lot more reasonable. A lot more reasonable. So we should be able to come back tomorrow and actually integrate. Thanks for watching, guys. I hope it was fun to watch. I feel like maybe I let context slip by again, but hopefully it's okay. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 3:40 now, so you can expect to see us anywhere between 3 hours ago and now. There's a YouTube link in the Twitch description if you're new. If you want to see things that we're working on, that is here. What you are seeing right now actually won't end up in like the normal YouTube playlist. It'll end up in the happy hour playlist because it's kind of like supplemental content. And the happy hour stuff gets kind of paywalled, which is unfortunate for you, but maybe fortunate for me because I need to make money somehow. If you want to support me, you know, Twitch, YouTube, Patreon, those are all good places. There's a GitHub link in the Twitch description. This will eventually go up there underneath the Swayland client repo. And I think that's it. Like, subscribe, Twitch Prime, and I'll catch you guys later. Oh, I guess I usually say I'll catch you guys later. Then I go to like say bye to YouTube, but this YouTube's not gonna see this. I guess they kind of will because they're the happy hour stuff, but the happy hour doesn't get goodbyes. Still curious if perf improved or not. Yeah, I don't really know how to check that easily. So I'm also curious, but not enough to do the benchmark right now. I apologize. I know that it would be cool to see. I apologize. Let's find someone to raid. L colon Q. All right. I guess we will turn off happy hour.